Another type of reaction that you're going to see very often is this, a hydroxide that is going to be phosphorylated. We're going to add a phosphate to the hydroxide. This is a controlling mechanism to isolate whatever that molecule is, and in terms of proteins, this can control activity. The phosphate comes from ATP converted to ADP. So the ATP has 3 phosphates, the ADP has 2. I'm going to transfer 1 from the ATP onto the hydroxide in this case. All right, and so what I'm going to do is I'm going to take 1 phosphate away from the ATP, and I show the whole molecule of ATP here. Now, when I look at that, we have ATP, we have the alpha, that's red here, the beta, which is that phosphate, and the gamma, which is this phosphate. And so in this type of attack, what I'm going to do is I'm going to have the ADP falling away. So I'm going to deprotonate the hydroxide. The hydroxide then has an electron pair that is on the oxygen that can attack. It will attack at the gamma phosphate. When I attack the gamma phosphate, what has to happen is this pi electron has to transiently be on the oxygen fully as a negative charge. That will allow 5 things to be bound to that phosphate, a pentacovalent intermediate. Now that is a high energy state structure, so I will reform the double bond to create a lower energy state, and as that happens, what I'm going to do is let the ADP fall off. And so the yellow becomes the ADP that falls off, and the phosphate where the red arrows are is the phosphate that's attached to the hydroxide that was original. So this is an attack at the gamma phosphate of an ATP. Now, there are 3 phosphates total, so you can attack at any one of these. The alpha attack, the gamma attack is the most often seen in most mechanisms. Here we have a attack now at what is called the alpha phosphate. And so if I take a look at the alpha phosphate, that is the one in this position. What the outcome is different. We're going to add AMP to the hydroxide, and we start with ATP, and a PI, or PPI, comes off, 2 phosphates together. So what we're going to show is the base will deprotonate the hydroxide, the oxygen will attack at now the alpha. Again, I kick up to form a transient intermediate, I kick down, and this electron pair going onto that oxygen will create the PPI that falls off, and then the AMP becomes this AMP that's attached. Now this is the second most often seen item in terms of the attack at the ATP, at the alpha. The beta can be attacked. It's not seen as often, but you can tell the outcome of this product because we start with ATP, AMP, the monophosphate falls off, and we have 2 phosphates that are attached. Again, my base will deprotonate the hydroxide. I will then proceed to attack at the beta. And the beta will kick up, kick down, and you can conceivably go 2 ways, but most often it is this electron movement in which the AMP is what falls off, and we have 2 phosphates that are attached to the hydroxide, which is the nucleophile. And so the AMP would be here, in yellow. And so that's AMP, and the two phosphates will be what's attached. There's the phosphate and the two phosphates. And so, in essence, this one is the beta, and that is the gamma phosphate that's attached. And so, we can attack ATP in 3 different ways: at the alpha, the beta, and the gamma. Gamma is the most often seen, followed by the alpha. The last is the beta.